Hello everyone. Thank you for the nice introduction. I'm going to tell you, as said, about, it's a long title, Advances in Mobile Crushing and Screening Technologies and Crushability Characterization. Those were the topics that Metso covered during the Rotate project. So what it's all about and why is it important? As background, I come from Metso, from Finland. We do track-mounted mobile crushers and screens, and I work for the technology development of these machines. The track-mounted devices are very handy and useful because they might be transported from site to another. There are a lot of benefits, and they can be used for crushing and screening in aggregates production, in mining operations, and nowadays more and more in recycled aggregates such as construction waste, concrete, asphalt, and so on. So they have good sizes, but the negative sizes, of course, are the emissions, and of course this is something that also the stationary crushing and screening units have. And the main emissions we try to tackle within Rotate were dust, noise, and carbon dioxide emissions. These all have negative influence on the worker health in the work site next to the operators who work with the machines, but also community acceptance, regulatory compliance are important factors. If thinking about, for example, like urban mining sites and things where the mobile crushers are very easy, but if they emit dust and noise, it's probably not good for operations for near inhabitants. Another big topic was the crushability characterization, and crushability characterization is something that is important when starting new sites, starting new projects in operation planning of crushing and screening. First, when you have the material, you need to characterize it so that you can select the appropriate crushing and screening devices. This is important because we don't want to overestimate or underestimate the machine type and size, because this is it's a waste of money and energy basically if you don't know which kind of equipment would be the best, and it's thereby relates to energy efficiency of the whole process. How it works and what we actually did during the project. We built up new technology for our prototype machines. This in the picture is a mobile impactor crusher, and this is a picture from Portugal, from Simpor site that was partnered in the project. And our prototype machine was crushing their limestone, and for the emission decrease methods we used there was the dust suppression system and the noise encapsulation. Dust suppression system was based on water spraying nozzles operating around the machine, and this is not something totally new. Of course, water has been used as dust suppression method for a long time, but in many cases you see like normal sprinklers or basically a garden hose with spraying some water all over the crushing plant, that it's not effective at all, because you need to know what kind of water droplets you need to produce to capture the most harmful PM10 part of the dust to keep the workers safe from issues with dust. For the noise also, it's not totally new that we want to remove the noise from the machines, but there's always this kind of a balancing between the dimensions and weight of our mobile unit. Of course, it would be if we would build very thick walls around the unit, that would probably get rid of the noise problem, but then we would compromise on the transportability of the machines. And here we use this kind of new type of multi-layer panels that around the crusher itself that should provide strong sound absorption, and especially to low frequency noise that the crusher is emitting. For the CO2, we had another pilot prototype that was piloted in Finland. That was an mobile tracked screen, and there we built up a new electrified powertrain to optimize the energy consumption. Typically these kind of machines have been relying on diesel engines, but now as world is going more electrified, we also want to see the potential in electrified powertrains. Of course, crushing and screening requires such huge amounts of energy and power that totally battery-based operation is not realistic at all, but we may use battery and then external generator to optimize the usage of the diesel engines, for example, and thereby save a lot of money and energy. In the crushability characterization side, this is I must say that this is mostly work of my colleague Elisa, who is the father of this idea. This is a new method that improves the correlation of the laboratory testing. It's based on the energy needed to comminution of the material, and it actually showed some good results that the correlation between the laboratory test and the full-scale test, that was partly true with the same impactor crusher and then with some stationary crushers, that improved highly with this new energy-based method. And that was also piloted with limestone, that is easier to crush, and for example with the hard granite in Finland, that is harder to crush. And crushability is considered as material property, but here it was again found that actually the feed size of the material changes the crushability behavior, so it's not a pure material property of the mineral that is crushed. So this was more of a new information to the research community partly. So the impact and benefits and results of our efforts in this emission reduction and characterization test method. The piloting in Simpor showed us really great results with the dust reduction. As a disclaimer, these kind of percentages are very case dependent. They are also dependent on the weather conditions, whether it's raining or windy, the situation changes. But overall we can say that we achieve very high percentages with capturing the dust, and we used very modern methods to measure it, because sometimes the measurement system is not very reliable, and we have this drone-based measurement system both for the noise and the dust around the machine to see what areas are like most dangerous for the operations around this kind of machinery. The noise encapsulation achieved 2 to 3 decibel decrease around the crusher, and the new electric powertrain of the mobile screen, which is actually seen in this picture. The lowest here, there's an excavator feeding the primary crusher, who is feeding the secondary crusher, and third there is the electrified screen. And with this kind of system we could use the screen own battery and electric powertrain, but also feed some excessive energy from the previous crusher, and thereby we calculated how we would save fuel and ended up with 27% reduction in fuel and in CO2 emission of this kind of a new electrified powertrain system with the mobile screen. The crushability evaluation itself, as said, showed us very promising results. That's something that also is an open report, was one of the deliverables, so that we are willing to share the information about the crushability test, and we would like to see that coming as one of the options, because of course this kind of testing methods in laboratory are quite standardized at the moment, so it takes some time to adapt new test methods to test these properties. But overall I would say that these piloting results and our work in Rotate has really give us concrete steps towards more sustainable screening and crushing operations all on the emission side and also in more scientific side on the crushability evaluation method developed. I think it's exactly 15 minutes from the start, so thank you.